This section explains the factors to consider when you select analysis and visualization tools. Throughout this course, you learned about the layers of a data pipeline. Raw data makes its way through the stages of the pipeline: ingestion, storage, processing, and analysis and visualization to produce insights about the data. This simplified diagram illustrates where analysis and visualization is in the data pipeline. Although each layer is distinct, how data is analyzed and visualized is tied to how it is stored and processed. Data engineers focus on the infrastructure that the data passes through. This three-part framework will guide you through the questions that you need to ask and the factors that you should consider when selecting data analysis and visualization tools and services. To build the correct pipeline, it's necessary to fully understand the desired outcomes based on business needs, the characteristics of the data, and who needs access to analyze and visualize data. Keep the end goal and business need in mind as you design the analysis and visualization layer of the data pipeline. Which analyses are needed to develop insights? What insights can be pulled from the data? What visualization would illustrate the insights? Does the customer need to generate a report or interact with a dashboard? The granularity of insight relates to the level of data that one has access to. A finance manager has access to data for their line of business, whereas the chief financial officer has access to all the data. Consider the grain size of the data that needs to be analyzed and visualized. Is it at a detailed level or an aggregate level? A key aspect of getting insight from your data is finding patterns. The right visualization will help you gain a deeper understanding of the patterns in your data in a much quicker time frame. Visualizations highlight one of the following 5 types of insights: key performance indicators, relationships between 2 variables, comparisons of variables, distributions of data, and compositions of elements that make up your data. As you consider the characteristics of your data, consider the volume, velocity, variety, veracity, and value of your data. How much data is there? At what speed and volume does it arrive? How frequently is it updated? How quickly is it processed? What type of data is it? Using the 5 V's as an overarching framework, consider what types of data you are dealing with: historical analysis or streaming IoT data, structured, semi-structured, or unstructured data. How will the data be visualized? In a periodic report or an interactive dashboard? For a fraud detection use case, consider the business needs first. For this purpose, 2 use cases are shown as examples here: rule-based fraud and machine learning in real time. Next, consider the characteristics of the data by asking questions. Rule-based fraud detection takes a reactive approach and provides a historical reporting of fraud cases. Structured data is ingested, analyzed, and reported in predefined intervals. In contrast, the ML fraud detection example takes a proactive approach. It provides the ability to detect fraud in real time as millions of transactions go through the streaming pipeline. Keep these questions about access to the data in mind as you select analysis and visualization tools. Where does the data come from? Will the data need to be combined from multiple sources? Who needs access to the data and at what level? Who can access the tools? Based on the principle of least privilege, a user's authorization to access data depends on their role in the organization. Consider this as you think about selecting tools and services to analyze and visualize data. For example, a business analyst or manager might be authorized to read the output that data engineers or data analysts create, but not delete or update it. An analyst could work with a data engineer to query data and be able to perform interactive analysis by using Amazon Athena. Domain experts and business analysts could ask questions and explore the data with a data analyst or data scientist to create a visualization by using QuickSight. A team might not include the roles with these specific titles shown on this slide, but someone on the team is likely performing the same functions. Here are a few key points to summarize this section. You learned about 3 factors to consider when you select tools to analyze and visualize data. For business needs, consider the granularity and format of the insight. For data characteristics, consider the volume, velocity, variety, veracity, and value of your data. For access to data, consider the functions of individuals who will access, analyze, and visualize the data. This section compares AWS tools and services that are available to analyze and visualize data. In this course, you have already encountered the tools and services that are related to the ingestion, storage, and processing layers of the data pipeline. In the ingestion layer, Amazon Simple Storage Service, or Amazon S3, and other external sources are used to store raw data. Amazon Kinesis data streams and Amazon Kinesis data firehose are used to collect data. An AWS Data Sync and AWS Database Migration Service are part of data migration. In the storage layer, S3, Amazon Redshift, and Amazon Relational Database Service are used to store aggregated data. In the processing layer, Amazon Kinesis Data Analytics and AWS IoT Analytics are used to process data. AWS tools and services that are commonly used to visualize and query data include Athena, QuickSight, and OpenSearch Service. In this section, you will learn about each service's features and compare them. Amazon Athena is an interactive query service in which you can use standard SQL to query and analyze data. Athena is serverless. You don't need to set up anything, and you don't need to manage servers or data warehouses. You can use Athena to query data in place and combine sources. This functionality is helpful for data analysts to perform one-time queries. The diagram on the slide illustrates an example of using Athena to perform one-time queries of data that is stored in Amazon S3. You can upload data from multiple sources into Amazon S3 and query it using Athena for one-time access to data. You can also use Athena to query aggregated data sets. Using Athena, you can query data that is stored in Amazon S3, but you can't update the data. Consider an example in which survey responses are stored in Amazon S3. Some responses aren't clear and need to be updated during the verification process. With the Apache Iceberg integration, the values are easily updated in Athena. The Apache Iceberg integration with Athena provides the ability to insert, update, and delete data in S3. Users can also track data versions automatically. Amazon QuickSight is a cloud-scale business intelligence service that connects to data in the cloud and combines data from multiple sources. QuickSight helps decision-makers interact with data in a visual environment. The service is designed to deliver easy-to-understand insights quickly. In this example of using QuickSight, tweets that are related to a specific topic are being analyzed and visualized. The solution uses QuickSight to create a donut chart, word cloud, heat map, and table of the overall sentiment, most dominant phrases, and associated and related tweets. QuickSight Q is powered by machine learning and provides a method for everyone in your organization to better understand your data. Users ask questions in natural language and receive accurate answers with relevant visualizations to help them gain insights from the data. When you need a visualization that isn't already in the dashboard, instead of waiting for the business intelligence team to get back to you, use QuickSight Q to get immediate responses. For example, you could say, "Show me last year's weekly sales in California," and Q provides an answer in a few seconds. OpenSearch is an open-source search and analytics engine. Amazon OpenSearch Service is a managed service that provisions all the resources for your cluster and deploys it. The cluster is easy to set up, operate, and scale. The Search and Analytics Suite is used for a broad set of use cases, such as log analytics, real-time application monitoring, website search, and clickstream analytics. The example on this slide uses OpenSearch dashboards to visualize data from support calls. The business need is to be able to analyze and visualize support calls, such as what is the subject of each call? How many were positive? How many were negative? How can managers search or review the transcripts of these calls? The solution uses other AWS services and tools to transcribe the support calls, and then uses OpenSearch Service and OpenSearch dashboards to search and visualize the data. Now that we have looked at the features of these AWS services, let's compare them. This comparison can help you know which service to choose for your particular use case. Athena provides interactive analysis using SQL, while QuickSight is for dashboards and visualizations. OpenSearch Service is for operational analytics. With Athena, you can start querying data instantly and directly in Amazon S3. With QuickSight, you can visualize data into insights quickly. With OpenSearch Service, you can visualize data in near real time. Athena and QuickSight are serverless, and OpenSearch Service is a fully managed service. Here are a few key points to summarize this section. You compared 3 AWS tools and services that are commonly used to query and visualize data. Athena is used for interactive analysis with SQL. QuickSight is used to interact with data visually and get insight quickly. OpenSearch Service is used for operational analytics to visualize data in near real time.
Welcome to this demonstration of using AWS IoT Analytics and Amazon QuickSight. In this video, I'll demonstrate a solution that runs on AWS to monitor remote devices. I'll start by using an AWS CloudFormation template to create a stack. The stack will create a device simulator that uses Amazon DynamoDB and an Amazon Elastic Container Service or Amazon ECS cluster, managed by AWS Fargate. Then I'll create resources in AWS IoT Core and AWS IoT Analytics to capture the device information and store it in a dataset. Finally, I'll show you how to create a QuickSight account and create an interactive chart to gain insights from the dataset. Okay, let's get started. The device simulator and the IoT components I'll be demonstrating are publicly available to be downloaded. Anyone who has sufficient permissions in their AWS account can deploy these resources. To find these resources, I'll go to aws.amazon.com/solutions and scroll down to Browse Solutions by Technology. Under Internet of Things, I'll choose More, and I'll look for remote monitoring of IoT devices. I'll choose this button to go to GitHub, where I can download the solution. I'll keep this page open and return to it in a moment. Now I'm logged into the AWS Management Console, and I want to deploy the AWS solution I was just showing you. I'll start by creating an AWS Cloud9 Integrated Development Environment, or IDE, in my account. This will give me a convenient place to work in. I choose Create Environment, give it the name Demo IDE, and accept all other default settings, and create it. I'll pause the video for a moment and come back when it's ready. Great! The IDE is now available. Next, I'll go back to the Browser tab where I have the GitHub page open and choose Code. I'll copy this HTTPS URL. Now back in the Cloud9 terminal, I'll type git clone and paste in the URL from GitHub and run it. I'll browse to the .yaml file, which is the CloudFormation template. This is what I'll use to deploy the device simulator. Before I run this CloudFormation template, though, I want to update a few details. First, I need to find the location of the container image from Amazon Elastic Container Registry, or Amazon ECR. I'll go to gallery.ecr.aws and search for IoT. I choose the one for remote monitoring of IoT devices and copy the location. Now back in the template, on line 562, I'll hardcode the location of the container image by pasting it in. This template can create all the IoT resources needed for the solution, but I want to show you how to create those resources manually in the console, so I'm going to delete the lines in this file that create those resources. I deleted the lines before this demo, so I'll paste in the updated file contents now. Note that other than the one line you saw me change, I didn't add or change anything else in this template. I only deleted some lines. In a moment, I'll show you what this template will still create. Now I'll go to the CloudFormation console. And from here, I'll choose Create Stack, and I'll choose Create the Template in Designer. Using Designer is convenient because I can create the stack without first creating an S3 bucket to upload the template file to. In the Parameters tab here, I'll choose Template, and then choose YAML, which is the format my template is in. I'll paste the template contents in from the Cloud9 editor, and then refresh the graphical view of what the template will create. Next, I'll choose the Up to Cloud icon, which launches the Create Stack wizard. I'll choose Next, and then enter the stack name, IoT Demo. I'll also set the number of devices to simulate to be 10. Now I'll work my way through the rest of this wizard, accepting all the default settings. I'll acknowledge that some IAM resources might be created, and finally I choose Create Stack. I'll briefly pause the video until the stack is created. Okay, the stack has been created. Here in the Resources tab, I can see that this stack created 31 resources, including 1 DynamoDB resource, 23 EC2 resources. These resources create the VPC that the Fargate cluster runs in. 3 ECS resources. This is, in fact, the Fargate deployment. And 3 IAM resources, including 2 roles and a policy, and 1 logs resource. So let's quickly look at the device simulator components. Here in the DynamoDB console is the table that was created. If I choose Explore Table Items, you can see that it has 10 entries, 1 for each device. And now I'll go to the Amazon Elastic Container Service, or Amazon ECS console, and I'll select the cluster that was created. Amazon ECS is a managed container service that you can use to run containerized applications. Fargate can manage the cluster for you. In this demo environment, the device data simulator is running on an ECS cluster, which Fargate is managing. If I select the Tasks view, you can see that there are 10 tasks running in this cluster, 1 for each device. Now that I have a device simulator, which is labeled 1 and 2 in this diagram, to send device information that AWS IoT Analytics can ingest, the next thing I want to do is create an IoT channel to receive the messages being sent. The channel, number 4 in the diagram, will create the IoT rule number 3, which you see here. But before I create the channel, I first want to create an S3 bucket to store data the channel will receive. I'll quickly go to the Amazon S3 console to create the bucket and name it my channel bucket and I'll just add some random numbers here. Next, I'll go over to the IoT Analytics console. I choose channel and then create channel. Let's name it my channel. And for storage type, I'll select the bucket I just created. I'll select this IoT role, IAM role, and choose next. I happen to know that the device simulator publishes messages on a topic named remote_monitoring. Here in this IoT core topic filter, I'll search for that and choose see messages. Notice that the messages are coming in from ECS. That's great. The channel is receiving data. For the IAM role, I'll select the IoT role and then choose next. And finally, I'll choose create channel. Now let's take a look at the IoT rule that was created when I created the channel. It's here in the IoT core console under message routing and then rules. Notice the SQL statement selects everything that comes in on the remote_monitoring topic. And then under actions, this data is sent to IoT Analytics. Okay, this is great. The IoT rule receives the data and feeds it to the IoT channel, as shown in steps 3 and 4 here. I can't create the IoT Analytics pipeline, number 5, until I have a data store. So I'll create the IoT Analytics data store next, and then I'll create the pipeline. Back in the IoT Analytics console, I choose data stores, and then create data store. I'll give it the ID my data store. For storage type, I'll choose service managed storage and then specify a time period of 3 days, because this is simply a demo. Next, I'll keep the data format as JSON and choose next. I'll choose next again and then choose create data store. Great. Now that I have the data store, I can create the pipeline. I choose pipelines and then I choose create pipeline. I'll name it my pipeline and then select the source and output resources that I just created. Next, notice that the pipeline is able to infer the message structure. The data coming into the channel is in a structure that the pipeline can parse. I don't need to add any pipeline activities, but if I wanted to process the data before it's placed in the data store, this is where I could do that. Notice that a few transform and enrichment type activities are available. You can also filter messages conditionally. Later in this demo, I'll show you how to apply filters at the visualization layer. But for now, I'll choose next and finish creating the pipeline. Now that the pipeline is created, I'll head over to the S3 bucket to see if the data is being written there. I'll drill down into these folders, also called prefixes, within the bucket. And notice all these GNU zipped JSON files. This is where the IoT Analytics data store I defined is storing the monitoring data for the remote devices. So the data is now being written to Amazon S3. I've built items 1 through 6 in this diagram. The next objective will be to get this data showing up in QuickSight. To do that, I need to create a dataset in IoT Analytics. I'll head back to the IoT Analytics console and choose Datasets. Notice what it says here. A dataset is a result of a SQL query run against your processed data. A channel, a pipeline, and a data store are required before a dataset can be created. The processed data that this refers to is the data in my data store. I choose Create Dataset. Notice that the description of SQL datasets says, a SQL dataset is a materialized view from a data store. That's what I want, so I'll choose Create SQL. I'll give it the name My Dataset, and for Data Store Source, I'll select My Data Store. I'll run a test query and verify that the results can be returned. There they are. For the actual query, I'll want all the data though, so I'll remove limit 10 from the end of this query and choose Next. I could optionally apply a data selection filter, but I don't need one. For frequency, I'll choose every 1 minute. This will be helpful for demo purposes. Normally, for an analytics dashboard, I might choose something less frequent. Because this is a demo, I'll retain the data for 3 days. And great, now I have a dataset. I'll choose the My Dataset link and then look at the content details. I'll choose Run Now. Remember, I just set it to run every minute, so I could just wait for the dataset contents to appear. Great, there's the data. I'll choose the name link, and here the results preview shows that the data is appearing in this dataset. That's great. Okay, so the monitoring data for the remote devices is in the dataset. In this last part of the demo, I'll show you how to create a QuickSight dashboard to display a customized view of the data. I'll start by activating my QuickSight account. I'll search for QuickSight here in the console's search field and choose that. I'll choose Sign Up for QuickSight. I'll keep Enterprise as the addition and choose Continue. I need to give it an account name. I'll type in my demo QuickSight account, followed by some random numbers, and I'll also type in an email address that I have access to. For IAM role, I'll use the QuickSight managed role. And for services it will have access to, I only need IoT Analytics, so I'll select that and clear all these others. And finally, I'll choose Finish. I'll pause the recording while the account is created. It only takes a minute or so. Okay, the account is now created. I'll choose Go to Amazon QuickSight, and I'll close this What's New window. Great, so this is QuickSight. Some sample analyses appear, but I want to create a new one. So I'll choose New Analysis, and then choose New Dataset. For the source, I'll choose AWS IoT Analytics, and I'll give it the name My IoT Analytics Data Source. I'll select My Dataset to import, and choose Create Data Source. SPICE, by the way, stands for Super Fast Parallel In-Memory Calculation Engine. It's an in-memory engine that QuickSight uses. Some other data sources provide a direct query option as well. So finally, I'll choose Visualize. Now I see the screen where I can create a chart. Notice the fields list displays the fields available in my dataset. I'll set the visual type to vertical bar chart. Then I'll drag the device ID field onto the x-axis of the chart. Next, I'll drag temperature to the value field and configure it to display the average temperature. Finally, I'll drag oil level to the group color well. This is a crowded chart and it needs some formatting. First, I'll format the device ID so that it doesn't display a comma in the number. Next, I'll expand this chart to occupy the full sheet. It's still a crowded chart. It looks like it displays too much data. Let's apply a filter to reduce the amount of data and to bring more specific data into view. I'll choose Filters, Add Filter, and I'll select Oil Level. Now I'll choose the ellipses or three-dot icon next to this new filter and choose Edit to make some adjustments. Let's set the chart to only display oil levels less than 110. And I'll choose Apply to update the chart. This looks like a more manageable amount of information. It might allow me to find some interesting correlations between temperature and oil levels. But for now, I'll disable this filter. Let's say I notice that particularly high average temperatures occur on one device. I can drill down into those details. For example, I'll select one of the bars above device number 1004 and choose Focus Only on 1004. That action applied a different filter, as you can see on the left. Now the chart displays specific information about this one device. If I hover over one of the highest bars in the chart, I can see that when the temperature of device 1004 hit 246 degrees, the oil level was 139. Is there a correlation between high temperatures and oil levels? If there is, this chart will help me figure that out. It's convenient to be able to drill down into such specific information in such a large data set. And by creating an interactive chart in QuickSight, you can expose this data to people who aren't as technical in your organization. As an end user of this chart, I don't need to know how to write custom SQL statements in order to extract information. I'll go back to the main view of the chart by disabling the filter. Next, I'll show you how to expose one of these filters to end users. I'll re-enable the oil level filter and then add it to the sheet. Let's give it the name Filter by Oil Level. I'll set the minimum value to 110, the maximum value to 200, the step size to 10, and choose Add. Okay, now I'm ready to publish this. I choose the share icon and select Publish Dashboard. I'll give it the name Remote Device Monitoring and choose Publish Dashboard.